to the Oxford Martin School seminar series for this term, Blurred Lines. This is not about a song. This is about the interface of humans and machines, and how machine intelligence and human intelligence can interact, how it could be a threat, it could be an opportunity, and we have a very rich set of seminars, of which I'm delighted that Chris Lintott and Brooke Simmons are kicking it off on where next for citizen science, innovative uses for crowdsourcing. Now, when Chris and his colleague Pedro Ferreira first came to me and said that they were cosmologists and wanted to work in the Oxford Martin School, my first instinct was, we about the 21st century and they about billions of years extinction cycles, and I couldn't actually see that it could be something that would be within our mandate. But they very rapidly convinced me that they thought about things and had methodologies that would be immensely helpful in meeting 21st century challenges. And I've really been delighted to see how the promise of what they held out has very rapidly come to be, I think, one of the most integrative and useful research programs within the Oxford Martin School, for reasons that Chris and Brooke will explain to you. So Chris is, has a doctorate and is an astronomer. He's the co-director of our program on computational cosmology, and his own research is on the formation and evolution of galaxies. He also leads Zooniverse, which is the subject of today's talk, and you might recognize him because he is the new Patrick Moore. So not to say that they have any physical similarity, but he presents The Sky at Night now on TV. And that too has been doing some really wonderful examples of crowdsourcing. Dr. Brooke Simmons is a James Martin Fellow within the same program. She's a postdoc at Oxford, and her work area has been on black holes. And we won't, I think, be discussing today what black holes are, because that could be a very difficult conversation. But she's widely cited, a great researcher, and we're absolutely delighted that she's come to Oxford and joined this program. So they're going to share the presentation for about 45 minutes, and then we'll have a chance for questions and answer. Chris.
Thanks, Ian. It's always a delight to come here, and I promise that there are very few equations in this talk. So those of you who are here, Ben, for a primer on galaxy formation and evolution, I'm afraid you'll have to come back another time. Maybe we can work that into next term's program. What we want to do today is really very quickly give you an overview of where we've got to in using crowdsourcing, or as we prefer to call it, citizen science, because it sounds better, in the service of scientific discovery, and outline a few of the key advantages. So I'll do that first. Then Brooke will share with you some of the thinking we've been doing about how we might take the same techniques that we've developed to understand fairly abstract things like, the formation and evolution of our entire universe, to more practical problems, and in particular to disaster relief. And then after Brooke's wowed you with that, I will come back, and I want to just end by talking about some of the practical problems we still have left to solve if we're to use citizen science to solve some of the 21st century problems and to scale beyond where we are already. But to explain where we are already, we do have to start with astrophysics, and we have to start with the problems that are caused by machines like this one. This is the Sloan Digital Sky Survey. This is an automated telescope in New Mexico with a 2.5 meter mirror. And Sloan, for 8 years, scanned the sky and took images and measured the distance to about 1 million nearby galaxies, about 300 million objects in all, but 1 million galaxies. And we can construct a rather pretty map out of this. Sloan was really about mapping our local universe. And so, for example, in this movie, we can start on the Milky Way and we can travel outwards through space. You have to watch the credits before you get to the universe, but this reminds me to tell you that this is about half of the whole survey volume. And so when we talk about doing astronomy, this is the universe that we're trying to explain. It's rather empty, there's a lot of space between the galaxies, but as you zoom outwards, you notice two sets of things. One is that the galaxies are not all the same. They differ in colour, and as they fly past the camera, you might be able to see that they differ in shape. But secondly, they differ in environment as well. This is a lumpy universe. There are places where there are lots of galaxies, and there are places where there are very few voids, like this area up here, for example, or this nice round concentration as a city of galaxies. And so really we're trying to explain how we got this mix of galaxies in this set of structures. Now the problem is that the methods by which we want to do that are still relatively simple. When you're confronted with a data set like this, your immediate instinct is to look at it. And we can look at it as a whole, as it is now, or we can zoom in and we can look at each of these individual galaxies. And it turns out that if we want to understand the history of these systems, the first thing we want to do is determine their shape. So for each of these galaxies, these systems of 100 billion stars or so, we want to write down what shape they are. So we want to distinguish nice spiral galaxies like the one in the middle from an elliptical in the bottom left, or a merger like that in the top right, or a galaxy with a dust lane like that in the top left, or a ring, or a warped galaxy, or a multi-merger system, or so on. And the shape of a galaxy tells you, it's a measure of its integrated history. So it tells you about how it's interacted with its environment and with each other over the years. The color of a galaxy gives you information about what's going on now. The shape tells you about its history for billions of years. And this task of sorting galaxies out according to their shape is one in which humans still have the edge over computers. And so this is a seminar series about combining and looking at the blending of man and machine. In this case, this is a place where humans still have the edge. Now I should probably clarify that, because I can see at least a couple of computer science people in the audience. So I'm not claiming that this is an inherently difficult task for machines. I think it's probably of the order the same sort of problem as face recognition, for example, which Facebook now does a pretty good job of. Or if you go to, I don't know if any of you have tried this, if you go to Google, you can use their reverse image search. If you upload a picture of yourself, for most academics, for example, that will correctly identify you and tell you what subject you work on, which is occasionally useful first thing in the morning. But the point is, face recognition has been solved because of an investment of many, many, many millions of dollars into that specific problem. The way that computer vision and artificial intelligence has evolved over the last 10 years is to solve specific problems rather than to build general systems capable of solving many problems together. So we can't take the work that's been done on face recognition and apply it to galaxies. If you gave me a $3 or $4 million grant, I could probably make a good stab at building a galaxy recognition program, but no one's done that. And so when we were faced with sorting these galaxies out by shape, and when we were faced with the million galaxies that Sloan could provide, we had no choice but to find people to classify these galaxies for us. We determined by experiment that students weren't willing to look at a million galaxies. The experiment's name was Kevin. He looked at about 50,000 galaxies and conclusively proved both that he was outperforming the computers, but also that that was about the limit of DPhil student tolerance. And so in 2007, we asked for help. We created a very, very simple website that looks very 2007. If you look at it now, it's got a random image of a galaxy and 6 buttons. We want to know if it was an elliptical galaxy or a spiral. If it's a spiral, we want to know which way the arms went. We have a button for a star and a button for a merger. And this site, simple though it was, that's all there was to it. There was almost nothing else on the site. There was certainly no deep, meaningful tutorial about what a galaxy was. There was no attempt to teach astrophysics. All it said was it would be really helpful if you would classify this galaxy for us. And the response was literally overwhelming. So the first couple of days looked something like this. So that's hours since launch versus number of classifications. we were doing 70,000 classifications per hour within a couple of days. And while we didn't continue at that pace, we've now done hundreds of millions of galaxy classifications. And that's only impressive because taken collectively, those classifications allow us to split the galaxies up into their constituent types. So I can now distinguish ellipticals from spirals, and I can distinguish spirals of one direction from spirals of the other. And in fact, I actually have more information than that. Because I've had lots of people look at each image, for each of these images, I also have I not only have a classification, I not only think this is a spiral, but I have a sense of how confident I should be in that, because I know that 9 out of 10 people said that was a spiral, whereas maybe I know that only 7 out of 10 people said this was a spiral. So I have some context to this information as well, and that turns out to be useful later. And so the first advantage of engaging a crowd in research is that ability to scale. We could take the measurement we wanted, the determination of the shape of a galaxy, and we could easily scale to 1 million galaxies. We actually over-classified. Even with 10 or 20 or 30 people looking at each galaxy, that's no longer a problem. But it turns out, that's the one we predicted. That's why we were doing the project. We wanted to scale. But there are other advantages to working like this. And one of them is the ability to make serendipitous discoveries, even at the scale of modern data sets, to pay individual attention to each and every image and thus find the really unusual ones. So in a project we're running, which has been running for the last few years, for example, Planet Hunters, we've found some really unusual things. So Planet Hunters is trying to do what it says on the screen. It's trying to discover planets around stars other than the sun. And those planets can't be seen directly, so this isn't about inspecting images, but about inspecting data. And what we're looking for is the blink that happens when a planet gets in front of its parent star. And what you see is you see a drop in brightness of often much less than 1%. But if you see a repeated pattern of blinks, then you can infer the presence of a planet. And mostly that can be done automatically, but the unusual planets require human ingenuity to spot. And so, for example, this is a set of data for 30 days for one particular star. Actually, 2 particular stars here. One star, 2 different time periods of 30 days. And what you can see is that there's a big blip here and here with a secondary eclipse marked in blue. And what's happening there is this is 2 stars going around each other. And so what's happening is not a planet getting in front of its parent star, but a star blocking the light from a star. So you get these very large dips. But then inside that data set, there's also marked as a planet transit in green here, a little blip, a little wink that marks the presence of a planet. So this is a planet going around not 1 star, but 2. This is something that no one even thought to write the algorithms to look for, but visual inspectors, including citizen scientists from Planet Hunters, have proved particularly adept for disentangling by eye this particularly complicated signal. And in fact, we have a confirmed discovery, rather unromantically known as Planet Hunters 1b, which is the first planet in a 4-star system. So this has 2 stars going around each other, the planet going around both of those stars, and then another binary star over here with the whole lot in orbit around its center of gravity. And this tells us something interesting about how these planets form, but you might have to ask me or Ian about that later on, and we'll discuss. So we've got scale, we've got serendipity, but I think the thing we've been working on, the thing that gives us hope that we can do this stuff in domains beyond science, is that we can also be fast. We have speed as well. And in January this year, for example, we partnered with BBC's Stargazing Live programme, which has that particle physicist Brian Cox running about talking about astronomy. Sometimes wish he'd stick to particle physics, but he is, of course, welcome to promote my subject as well. And this is what the page, so here we're looking for distant galaxies. We were in fact looking for distant galaxies whose light has been bent by the passage near and nearby galaxies. You have a lensing galaxy, which lenses the image of a distant source and makes it visible to us. These are nature's telescopes, and they allow us to see further and more deeper into the universe than we would otherwise be able to do. So space warps, because Brian Cox stared down the lens of a camera and said, everyone go to spacewarps.org and classify, and because our servers held up, and we understood how to cope with the flood of Brian Cox fans obeying his every whim. This is the third year of doing this, and we've just about learned how to cope. We got something like 7.5 million classifications in under 48 hours. It's a huge amount of human effort devoted to one problem, which we knew how to use. We actually got the first 1 million classifications 20 minutes after we launched the project on air. And within those first 20 minutes, we'd found our candidate distant galaxy. So this is the galaxy we revealed on the program. So the orange thing in the center here is a nearby system. And the red ring you can see here is one of the most distant Einstein rings, this kind of lens system known. It's light has traveled for about 11 billion years to reach us. And we've now spent the last month pointing every telescope in the world that we can get our hands on at this thing. It's a really exciting discovery, but it was made within 20 minutes because we were able to direct human attention successfully to the right images. So scale, serendipity, sorry about you can tell I've been writing proposals. Scale, serendipity, and speed combined. And we use all of those in the Zooniverse, which is our collection of now, there are about 20 live projects. This slide happens to show the astronomical ones, but we've also run projects with everything from papyrology, transcribing the Oxyrhynchus papyri, through to ecology, keeping an eye on the Serengeti, and even to a partnership with Cancer Research UK. But we're not satisfied with that. We want to see where else we can direct our volunteers' attention, and that's what Brooke's going to talk about now. I shall.
Last time we had 2 speakers, the microphones went a little bit nuts. Can you hear me? All right. So, as Chris said, we've certainly branched out a bit, but mostly into areas of research. And in order to branch out further, I think one of the things that we should ask is sort of, what do we do at the Zooniverse? Essentially, what we do is harness cognitive surplus. We ask people to look at images and find patterns. And we do that by asking the right questions. We ask questions that allow non-experts to make real contributions to research. And we've had very good success at this. I don't think Chris mentioned it, but we've had more than 50 refereed academic publications across our many projects. So that is at least one measure of how we think we know what we're doing. So to branch out beyond science and beyond pure academics, the first thing we sort of have asked when we've been delving into the issues of humanitarian response is, well, what would happen if we turned our attention turned it from space and turned it toward the Earth and specific parts of the Earth? What if instead of asking people to classify patterns and recognize features in these images, we ask people to look at images like these? So these are images from a couple of disasters, a couple of pretty significant damage showing images. And what we'd like to do is, ideally, we'd like to collect images from multiple sources. We'd like to crowdsource the data, and then we'd like to crowdsource the response. So we'd like to start by saying, all right, let's look at all of these particular sources from which we can capture data, for example, Twitter, Instagram, Facebook, and so forth, and then also take images that aren't public necessarily, and maybe get some use out of satellite data or UAV data, and ask specific questions, and then gather the answers to those questions and present them to first responders, decision makers, people who can make real use and deliver immediate help to people. So to take an example of this, I'm going to take you through the rightmost image. Okay. In the aftermath of Hurricane Sandy, this image was tweeted many times, a flooded McDonald's. And okay, let's take this tweet as an example. A computer can look at this tweet and say, there might be something going on in Virginia or Virginia Beach. There's the word flooding. This might be interesting. There's a picture. And say, we have to ask a person, though, how bad is the flooding? So if you're a person and you've come to this and I'm asking you for my crowdsourcing project, you can say, okay, the flooding is quite severe, right, definitely. It's in Virginia Beach, and I can mark where that is on a map. If this image was geotagged, then I could mark it very accurately on the map. And then if this same tweet was showed to multiple people, you'd build up kind of a consensus of what that result was. And if you showed multiple different sources of information from that same area, you could build up this map and see where the features are. right? Then that map could be delivered to first responders like the Virginia Beach Fire Department, nice logo, and in this case, since it's a US crisis, to FEMA, a larger decision-making organization would be interested in that, right? All great, except first problem. This image is not an image of a flooded McDonald's in the aftermath of Hurricane Sandy. This is an art installation. This is called Flooded McDonald's, and it's meant to make a political statement. And so, okay, how do you see that from the tweet, right? Unless you're a person and you've seen the art installation, that's going to be a bit difficult. So we have this problem with authenticity when we're talking about crowdsourced data, where the people are contributing the data, and we're taking data from sources where it's not necessarily meant for disaster relief. So this is the first challenge that we're going to have to deal with or avoid somehow. Now, the problem of authenticity isn't necessarily hard. Sometimes computers can handle it. Sometimes a person can look at it very easily. If this image was tweeted after a tornado, for example, that's not too hard to say, well, that image obviously isn't real. In fact, a computer can look at this image, and given some algorithms that we now have, could probably give a pretty high degree of certainty that this is photoshopped even without knowing about Sharknado. But a computer cannot tell you that this image is photoshopped. And actually, even an expert on Photoshop in investigating this image in detail won't tell you this image is photoshopped because it isn't. This is a real image of a staged scene, right? It wasn't intended to be staged for this purpose. Nobody was necessarily being malicious in tweeting this. It was just wrong. Right, so this is a real challenge and a significant problem, and there are ways to avoid it. But even if you can overcome it, right, once you've overcome the challenge of authenticity, then you have another challenge, which is that even if an image is authentic, even if a tweet is authentic, it might actually not just be that useful. Right? A lot of the tweets coming out of Typhoon Haiyan this November were tweets like this: pray for people, stay strong, and various things like that. And that is, in some sense, authentic in the sense that this is in many ways what social media was designed for. It's one use of social media, right? So it's not somebody trying to do the wrong thing, but it's just not that useful. And even in cases where it might be useful for aid organizations in the sense that it's an appeal to get money, and I put this up because who doesn't love Tom Hiddleston, really? But an appeal for money with a link saying you can go there and you can give money, that's great, but that doesn't help Oxfam, right? That doesn't help people on the ground who are trying to actually deliver real and tangible aid. So this challenge of finding a few needles in many haystacks is really very significant. I did try to do this a bit after Typhoon Haiyan and look through the tweets, and they're almost all like this or even less informative. So, all right. Two challenges that we need to overcome or get around somehow in order to address this challenge, which is the challenge of accuracy, right? How do you deliver accurate results? You've got some sort of data, and you've got people to look at the data that you've broken up into pieces that are manageable. What do you do after you've got these volunteers looking at this data? What's in the black box, right? How do you deliver accurate, reliable, and timely results? Well, I would argue that, and part of what this talk will be arguing and has argued, is that that is what the Zooniverse does. We take this diverse data from many different people of many different expertise levels, we assess the expertise levels, and we deliver that set of results in multiple ways. So the way that we've started trying to address this and started trying to plan out how we're going to deal with humanitarian crises in a crowdsourcing sense is by basically just ignoring the problem of authenticity and value, not in the sense that it doesn't exist and we're going to pretend that it doesn't, but in the sense that we're going to use a data set that doesn't really have that problem. So we're going to use satellite data to start, right? So that we can focus on, well, we already know quite a lot about how to deliver accurate results. One of the things that we're really working on right now is the delivery of the results, right? In our science projects, we need to deliver scientific results that are of use to the science team. Right? In the case of a humanitarian crisis, we need to deliver results that are useful to someone who's trying to provide aid to, say, an earthquake. So I'm going to take you through a couple of examples that show some different kinds of results that we might want to deliver to people and how we would do that. So this is Haiti after the 2010 earthquake. This is one particular street in Port-au-Prince. And you, as a person, can immediately see many areas that first responders, decision makers might be interested in this image. A computer would have kind of a hard time. A computer can be trained to find the cars pretty easily, can find clouds pretty easily, but most other features are a little bit difficult. You can see immediately that there's quite a bit of building damage over in this corner, among other places. You can see where the roads are in this image. You can see actually not just where the roads are, but you can see that these roads are pretty much okay, that they're pretty passable, and you could probably see if they weren't. In this particular image, this is a very high resolution image, you can actually see individual people, which may be useful, although in some instances of crises, what aid organizations want to know is not necessarily where one person is or two people, especially in a populated area. What they want to know is where are many people, where are people gathering? And that we can see at the bottom left, those are signatures of temporary shelters having been put up. And so you can see these blue tarp-like structures. Those you don't need excessively high resolution information to see. You can see larger structures without needing to point your most accurate and most high resolution, sort of before being classified, satellite at it. But okay, once you've got all of this information, then you can show this to multiple people, you can deliver that result. Excellent. Now some of these features are going to be kind of universal in terms of the different crises that we might face, the refugee crises or earthquake or typhoon, for example. The reason is essentially that many of the problems that we're dealing with are essentially people problems. We want to know where the people are in distress, where the people aren't, where the people can go if the roads are impassable, for example. This is part of the Philippines. I believe it's Tacloban, but I might have pronounced that wrong. In any case, again, you can see pretty clearly that there's quite a lot of damage in this image. Even without knowing much of the context, without knowing much of what this used to look like, you can mark, for example, quite a lot of damage there. You can mark triangles all over this image. You can also see, in this case, this is a typhoon, there's some flooding in this image. And you can make a guess, even though you don't exactly know where there is supposed to be water and where there isn't. You can make a guess that there's probably flooding here. Now, in many cases, one of the things we're going to want to use is a before and after kind of movie that we can flip back and forth. So if I show you a before typhoon picture of this, right, you can actually see, okay, so now that area in the top left is a little bit wet already. It's kind of marsh-like, but it is quite flooded compared to what it was beforehand. But in fact, this image here in the bottom middle that looks like a kind of river, that still looks like this. That is fine. That's not flooding, so we wouldn't need to mark that. And so you get an extra information by adding before. And also, you can see right below that triangle, right? That patch right there, those roads used to be connected, right? And they're not anymore. So you could see these images, and you could mark this as an impassable road so that first responders know that that is not a useful place for them to go. Now, in terms of how we actually deliver this, there are many ways to do this, but one of the first ways is to start with consensus, just the fact that we show this image to multiple people to get multiple independent classifications. You really want to take nobody's word for it, but you trust the group. Now, since we haven't actually deployed this on a live crisis yet, I don't have an example project for that to show live, but I can show you another astronomical example of a place where we have implemented this already, and we can just translate this across. The Milky Way project is a project to map the bubbles that are blown in interstellar gas in our own galaxy when new stars have formed. And you can see in this interface where we ask people to draw the bubbles on the image that you can customize the bubbles quite a lot. And so you can draw their shapes and their ellipticity, you can put holes in them, you can really add a lot of information. And that is very, very valuable to us, not just because it tells us about the data, but it also tells us about the users. How much attention a person pays relative to other people tells us really how much they care, how much value they're trying to add. So that's extremely valuable. Now, if we take those results and we put them on, this is a larger zoomed out portion of the same part of the sky, we can layer those people and weight them according to their expertise, which we're developing new ways of assessing, and Chris is going to talk a little bit more about that, I think. We can layer those classifications on top of one another, and we get a heat map right? So if this was an area of flooding, for example, that we were asking people to map flooding, you could pick out from this very quickly, if I delivered this to FEMA or if I delivered this to USAID or any other organization, you could pick out very quickly, well, okay, I can see there's very likely flooding in these spots, and because we have multiple classifiers in the same sense as astronomy, we get a sense of how certain we are that that actually is a real result, right? And you can see that there are many places where 1 or 2 people marked things, but no one else really did, and so those are kind of low-level results. Adding another layer on top of this, what you can do is, with some more sophisticated work, you can add a thresholding analysis. And so you can say, all right, I'm going to take some threshold above which I say that's definitely a feature, right? And from there, I can say, well, say that road up there at the top right, that looks like it's definitely an impassable road. So I'm going to send out an alert to the first responders who might need to know that, because that's immediate information that's going to be particularly valuable. It doesn't mean it's exactly right, but it means it's quite a bit more accurate than anything that can be delivered right now. And of course, there's more to be done here. We're working quite hard on various things, including ways to make this more efficient, ways to go this far to get this kind of result with fewer classifications. So a lot of work still needs to be done. In particular, what we're working with right now is we're working with organizations like the UN to ask them, how exactly do you want this information formatted? What kind of results do you need us to deliver to you? How would that be most useful to you? So from here, I'm going to take it over to Chris again. But just to say, this is very much in progress. Stay tuned.
Thanks, Brooke. So what we've heard from Brooke is the fact that there is a need to do crisis image analysis, and that we at least see analogies from our astronomical work. But there's a charge on us, I think, when we start to do things in the real world, and indeed actually just to cope with the size of data sets that we can see coming from future scientific projects, to think much more deeply about how we use our classifications. We've been able to be lazy until now. With Galaxy Zoo, we were completely overwhelmed by the response. Thanks to Brian Cox, we had 8 million classifications for spacewalks. And so there's not too much need to optimize. We'll get enough people to look at enough images eventually. But that's not always going to be true, and it's not going to be true as we expand the Zooniverse. Luckily, we found colleagues from all sorts of departments who are interested in thinking about this. And probably a nice example is to go back to spacewalks. So this search for distant galaxies. And if you take part in that project, you'll discover pretty quickly that we're playing games with you, that you don't always see an image that we need classified. So sometimes you'll see, as in this example, a simulated distant galaxy. And so we're doing that partly because people tell us they want some feedback, so it's a nice feeling to know that you caught a simulated galaxy. It's hopefully quite a nice feeling to be corrected, or at least gives you some confidence if you're told that you've missed something. But this illustrates the basic point that every classification that's carried out through an interface like those on the Zooniverse not only gives us information about the thing being classified, but also gives us information about the classifier. And so a lot of the work we're doing is trying to interpret both pieces of that information. Until now, citizen science projects have thrown away the information about the classifier and worried only about getting information about the thing being classified. As if you look below the hood on spacewalks, for example, this is what the view looks like for individual images. And so what you have here from left to right is each dot here is an image being classified. And we're plotting on the y-axis here. This is the probability that it's a real distant galaxy, a real gravitational lens. You can see that most of the systems over time come down here. We determine that they're not classified, and some go up. So we end up with a few new candidates. So blue here are simulated lenses, and red here are images where we know we've had experts inspect them, and we know that there are no lenses. So this is a sign of a Zooniverse project working well. But of course, I can make a similar plot for the classifiers. And so we can split classifier behavior up. The x-axis here is the probability that somebody will say there's a lens there when there is. And this is the y-axis, the probability that they will say there isn't a lens there where there isn't. And so if you like, the bottom right here is populated by optimists. These people see lenses all the time. The top left is populated by pessimists. They almost never see anything. And an ideal situation is to have people up in the top right. And the point is that as I know where people are on this graph, I can assign them tasks differently. So if I know you're a pessimist, then maybe it's a really good idea to make sure you see something that I'm pretty sure is a lens. Because if you're a pessimist and you agree it's a lens, then I can be very certain that it's true. If I know you're an optimist, then maybe I don't take it quite so seriously when you discover your 4th distant galaxy of the morning. And so we can use this textured information to make huge improvements in efficiency. We've actually done that. So there was a project we ran called Galaxy Zoo Supernova. This was a difference mapping project. So on the left here, you have 2 images of the same galaxy, a new one taken within the last couple of hours, a reference one and the subtraction. So this is this minus this. You can see here there's a new star, a supernova, the death throes of a dying star, in fact. And we got people to answer a series of questions in a short decision tree, and we found we could distinguish image artifacts and passing asteroids and things like that from real supernovae. But we also found that if we, I'm just going to skip these, that if we took advantage of what we knew about the classifiers, we could hugely increase efficiency. So what you're seeing here is the false positive rate over time, so being versus the true positive rate, so being at the top of this response curve is good. And the yellow and the green dotted lines are the trajectories of projects that just take random classifiers and just assign a task randomly to everyone in the room. So you get the first one, you get the second one, you get the third one, you get the fourth one, and so on. And what you can see is you do quite well to begin with, and then it takes you a long time, many, many classifications, to get to a point where you're very reliable. Whereas if I'm allowed to assign classifications, so I know that you're particularly good at faint fuzzy supernovae, so you get that one, and you're particularly good at the bright stuff, so you get that, and you don't get distracted by particular galaxies, so you get the ones with beautiful galaxies in. If I can make that sort of judgment automatically, then I can very quickly get to an accuracy, and we get the same scientific accuracy with less than 20% of the classifications. So we can actually improve things. And here's the view of people within that project. So here, this is a slightly obtuse plot, but I think it's worth it. So the scores here, so the way the decision tree worked was that it could give people one of 3, or give a supernova one of 3 scores, -1, which is not a supernova, 1, which was typically something that was astronomical, like an asteroid, but not a supernova, and 3, which is a supernova. And then we looked up the ground truth. We went and followed a set of these up with a big telescope. And so 1 was things that are actually supernovae, and 0 were things that were not. So if you think about it, these people are the ultimate pessimists. Whether they saw a supernova or not a supernova, they said there was nothing there. We got some optimists over here, weren't always sure about supernova versus sort of supernova, but they thought there was something there all the time. These people are interesting. These are pessimists. They never say anything's a supernova, but they still discriminate between the 2 types. So if I know that's how they're using the site, they become very useful. These guys are sure about everything. I think we all know people who would lie in this category. And you adjust your feeling about their statements, so we know how to treat them. And these are the people behave, only this group, which amounted for less than 20% of the population, behaved the way we thought people would. But we could use all of these other people once we know their behavior. And we can even go further. We can look down at individual people. So these are trajectories for individuals, people's behavior on supernovae. So I like to think of these as Toblerone plots. So the long line here is time. So this is somebody's first classification. This is their last. As you can see, these are people who've done many classifications. And actually, just look at the blue line here, for example. Let's take this one, because I can actually reach it. A perfect classifier would always give a score of -1 to something that isn't a supernova. So the perfect classifier will have this blue line running across this axis here. Actually, this person's not doing too badly. But what fascinates me about this plot is this point. There's one classification between here and here, and this person suddenly got much, much worse. And so what happened, well, we can speculate, perhaps they had a drink. We've checked, this is 11 o'clock on a Monday morning, so I'm pretty sure that's not the explanation. Perhaps they gave their login to somebody else. Maybe. What I think actually happened though, this is somebody changing their mind about what one of the questions on the site means. They've made a wrong, because of what they've seen, they've made a decision, oh no, I'm not supposed to be classifying it like that, I'll change my behavior. And as you can see, they changed their mind back a little later on. And so what we want to build, and what we're actually working on, is a system that can track this stuff in real time. And so if you see this jump, then maybe we put some more simulated images in here, or maybe we prompt people to go back and retrain or whatever. Slightly Orwellian, it's the sense of the system watching you, but it's that sort of rich interaction that determines what it's worth showing you in particular at any one time that we'll need if we're going to do things as the images come off the satellite. Now the other way we could get more efficient, so the other way to get more, and I should say by the way, I meant to mention that a lot of the code that we're using to do this is straight out of standard machine learning routines for imperfect classifiers. Steve Roberts and co in engineering, people in the university's robotics lab, have lent us their codes, and they use this type of thing to build driverless cars. So if you're building a car, you have many subroutines all recommending decisions, and then you have a central piece of code that makes a decision about which subroutine to listen to. And that analogy is exact. So what we're doing here is we have many imperfect classifiers that happen not to be subroutines, but happen to be people. And we're making a central decision about which person to listen to at any one time. The only problem is that subroutines don't get bored, and people do. And so what we've had to do is add to the system a sense of how interesting an image is for a particular user. So not just how good they are at classifying it, but how much they want to classify it. If you're the best person in the world at classifying faint, fuzzy, boring galaxies, it does me no good at all to feed you a constant diet of faint, fuzzy, boring galaxies, because we will drive you away. So the other way we can improve efficiency is to pay more attention to that side of things, to try and pay more attention to the fact that we have people in the black box that Brooke drew to describe the Zooniverse. You have to think about which people we have. This is the visualization of effort that went into a project called Old Weather, which was transcribing weather information from 1 million pages of Royal Naval logbooks from the early 20th century. And each square here is one volunteer. And so over here we have the super volunteers. I can probably name most of the people whose boxes are over here. I won't, because I'll get the order wrong and then we'll get emails. Whereas these people I've never met. These are the people who come to the site once. So in some ways, messing about with machine learning and all of this stuff is intellectually interesting. But probably what I should be doing, you might argue, is just make all of these people do twice as many classifications. If I could get if I get everyone who comes to the site once to come twice, then I add 50% to my efficiency of my project. And I want to argue that that's really hard, which is perhaps obvious. But you see, what happens at this point is people start talking about games. There was an article in The Guardian this weekend that described Planet Hunters as a game for citizen science. I got an email today from an organization that invited us to apply to a game design award because they were impressed by what we were doing. And there are games in the world that do good. The best of them is a puzzle game called Fold It, which comes out of a lab at the University of Washington. It's a collaboration between a game design studio, an academic game design studio, and a bunch of biologists who were interested in determining the 3D structure of proteins. And if you go to Fold It, you download it, you run it, what you discover is that you get a puzzle that looks a bit like this, and your task is to manipulate the proteins to reach the lowest energy state that you can find. They have an advantage, they can give you a score. And so you learn how to use the tools that they give you to manipulate these proteins. And it's an incredibly clever piece of work. Some of the structures are complicated, but the tools that they give you encode essentially a very specific advanced degree in biochemistry. So if hydrogen bonds can only exist at particular angles, then you learn that the green things can only be moved with a spanner that only allows you to move particular jumps. And so these things can only be stretched so far, the main backbone, and so the tools that you use will only let you stretch them that far. You don't need to understand the biochemistry, you inherit all of this information. And Fold It has been hugely successful. It competes successfully in blind competitions with the best machine learning to find actually medically interesting protein structures for drug discovery. So this is a game, and it's a game, it comes down to this score up in the top corner. So this works because you can calculate, when somebody manipulates a protein structure, you can calculate a score that's related to the energy of that protein structure, and you can give a sense of whether you're doing the right thing or not. There's a completely different example, one of my favorites in this space. It's a game from the Finnish National Library called Mole Bridge. That's what it looks like in play. This was an attempt to transcribe the entire newspaper article library or archive of the Finnish National Library, and they wanted to design something that people who didn't speak Finnish would do, because there aren't enough people who speak Finnish, they thought, to go through the entire archive. And so what you had to do is you transcribed this word at the top. When you transcribed it, you could use this keyboard to get the special characters, it added to a bridge. These moles would walk along the bridge, and you had to get them to their sweetheart in the top right before they fell off and died. This is an essential. You said that you worried that we weren't going to contribute to the 21st century's problems, Ian, and yet here we are saving moles. But what I really like about this is this end word you can see is pink rather than white. And what that means is that this word hasn't been verified. So as soon as you put a word in, it would appear as a pink part of the bridge, and then it would be given to another player. And if they agreed with you, it would become a nice white solid bit. And if they disagreed with you, it would vanish and your moles would plummet to their doom, which was very upsetting. And this worked so well that they indeed digitized the entire Finnish National Archive of newspapers in a couple of months. And sadly, they took the game down, which has meant that I've got some astrophysics done. And so my point is that it is possible to design these games that encourage huge numbers of people to do apparently obscure or abstract tasks in their spare time. And so you might think that the easiest way for us to improve the Zooniverse, to get more classifications, is to gamify, to add game-like elements to what we're doing already. And we've dabbled with that a bit. So we ran a project with the SETI Institute looking for aliens. We had live telescope data. We had people look for signals, and if signals were found, the telescope swung back to follow up on alien signals. And I should point out that we haven't found any. I promise I'll come here and announce it when we do. But to encourage people to take part in SETI, because of the partners we had, we did what everyone does. We added badges. So you could win badges for participating in a conversation, for classifying 5 days in a row, for spotting something that caused the telescope to move, for looking at a signal from a planet that had been discovered by planet hunters. We even created a badge for "You have discovered aliens," which would have been automatically posted on users' Facebook accounts. So this is how the world would have known had we found any aliens. But what was interesting is that the badges did indeed change people's behavior, which is why we put them in. So if we gave a badge for 25 classifications, then we found that more people would reach 25. So the people who would otherwise have done 21, 22, 23, or 24 would tend to go up to 25. And then we found that almost everyone who got a badge for 25 stopped, because they'd been incentivized, so their motivation, which previously had been to help science, had become, I want to get a badge, and thus they stopped when they'd achieved their task. We've done similar things with Galaxy Zoo and found that if you give people a score, the best classifiers leave, because they stop thinking about helping science and they start thinking about trying to win the game. And when they have a good score, they've won the game, and we're trained to stop playing games. Another way of saying this is that these are terrible computer games. And one has to go the whole hog and develop Fold It or Mold Bridge and create a truly engaging game experience, rather than this halfway house with citizen science with some game-like elements plugged in. We see that most clearly, I think, in some interesting responses from the old weather project I mentioned, so transcribing logbook entries like this one to give climate scientists at the Met Office details. And so we were a bit worried that this looked rather dull, and so we added ranks. So if you join the crew of a ship, you classify away, and if you classify more than other people, you can become the captain of the ship. We thought this was quite exciting. But researchers led by Alex Everley at University College London did interviews with a huge number of old weather volunteers, and the responses, I just want to show you a couple of them, were really interesting. So this person, this is an advanced classifier, said, look, I was never even close to becoming captain. It seemed like you had to transcribe 10 times as much as I was transcribing, or 100 times what I was transcribing to even get towards that. So I never gave it much thought. It seemed like it was more of a competition for the harder core users. So any game-like system encourages only the people who are winning. Everyone else suddenly feels excluded. But even the people who are winning said interesting things. This is a captain of 2 of the ships who said, yes, I did find it motivated me, but I also found it quite stressful. I'm quite a competitive person, and when I got to be captain of a ship, I wanted to stay there at any cost. And then somebody else came along that had more spare time, and so I get quite stressed trying to stay ahead. And my point, I think, is that this is not a positive experience. And at least one point of these projects is to give people, whether it's humanitarian relief, and you want people to feel like they've done more than just contribute a fiver, you want them to feel like they've contributed their time, or whether it's my attempt to get people to think differently about science. This is not a good way to trick people into classifying science. I rather liked this quote. This is from Stack Overflow, the founder. If you know Stack Overflow, it's an intensely gamified, points-driven programming mainly site, so you go there for any answer to development queries you have. He said, in the history of the world, gamification has never gotten a single person to do anything that they didn't already basically like to do. And what we're trying to do here is incorporate some quite abstract tasks, science or scanning satellite photos, into people's daily lives. They don't already want to do those things, and points aren't going to help us. What we have to do instead, I think, is build a deeper experience. Sorry, I'll explain the National Gallery if somebody wants to ask me about it. And we've started trying to experiment with that. So I just want to end by describing a project that I think gives you a different sense of the vision for where citizen science is going. Never mind mucking about with badges and games. We ran a project last summer called Galaxies Quench. And the tagline was that we wanted people to experience science from beginning to end. Which suggests we need some new marketing people, but never mind. The sentiment was genuine, which is that what we did with Galaxy Zoo Quench was we started with the Galaxy Zoo task, classify these galaxies, and then we gave people a set of advanced tools to explore the results. And about 1/10 of the users who started classifying used the tools, and then between them they discovered a genuinely new scientific result about how galaxies behave after they've merged. They're able to produce the plots that you need to show that result. And then 1/10 of those people went on and are now working with researchers on a collaborative online tool to write their own papers. And so we now have people going from not being engaged with science to clicking on a Galaxy Zoo-esque website to doing free-form data exploration of the kind that begins a PhD student's life in academia through to trying to write up their own results. Now that's a way of keeping people engaged. It increased the number of classifications we had overall, but that to me seems a lot more promising in the long term than giving people a badge for finding aliens. So hopefully that's given you a sense of where we're going and the kind of things that we're thinking about. I think we've got plenty of time to discuss any aspect of that, possibly except the aliens that you found particularly engaging. Thank you.
Great, Chris and Brooke. That was really fascinating, and I'll certainly give you both badges if you discover aliens, and much more. We'll open a few bottles of champagne. Who'd like to go first?
They all want to go and try and look for aliens. That's the thing.
So something that has worried me a bit about this.
Yeah, by the way, this is being webcast live. So if you don't want whatever you say to be broadcast, then I suggest you don't say it.
So something that has been worried me a bit about this is, are we having different projects competing for the same pool of players, or are there different pools and maybe one could develop better tools for figuring out how to get different pools so projects don't trip up each other?
Yeah, no, I think that's a really good point. And that was actually one of the motivations behind creating Zooniverse as a pool of shared community, really, so that we didn't have to re-advertise ourselves to potential players. From the evidence, what we see with Zooniverse is publicity for or the launch of a new project increases the number of classifications we get on other projects. So when at 20 projects, we're not yet cannibalizing. We see that actually anecdotally when Fold It get press. Galaxy Zoo gets busy. And I imagine that's people being reminded that Galaxy Zoo exists by the coverage of citizen science. So far, we're nowhere near the point of projects cannibalizing each other. However, I think that there's a point where you do want people to transfer from one project to another. And that's when you want to try and do things that are more difficult. So we have a project called Cyclone Center that I think is really interesting and important. It's classifying historical images of hurricanes with an effort to try and see whether global warming has made a difference to the strength of hurricanes, which is a hugely contentious point. Cyclone Center's pretty hard. I mean, everyone in the room should go and try it, but it's pretty tricky. It has a long lead-in time. There's quite a lot to learn to be able to do it, and it rewards detailed study. Now, I think the only reason we've got a decent audience for Cyclone Center is we'd already got a bunch of people trained into the idea that they could contribute to science, like Galaxy Zoo and some of the other projects. They were willing then to put in the time. I think if you got somebody cold and said, go to Cyclone, and I can support this with data, and went, go to Cyclone Center, you've never thought about being a citizen scientist, and it's going to take you half an hour to get started, I think that's a very difficult proposition. So I think what we actually need to do is get much more intelligent about how projects feed off each other. My dream of being able to direct our crowd of 1 million people and say, okay, today it's Venus and next week it's disaster relief, and then it would help if you could all transcribe weather records. It's never going to work. But I bet there are more interesting things we could do to try and direct people to projects that they'd enjoy.
Hi, thank you for the talk, both of you. That was fascinating. I didn't realize how much classification of the people you guys were doing in the back end. At one point, it started to seem like the XKCD joke where you spend more time writing software, not about optimizing the algorithm, but optimizing the people. But two questions that come out of that is, could you actually use that software to as a high school counselor, guiding people towards different projects, or even helping them in the school curriculum, kind of hone in their skills? And the second part is, do you see an extension of the Galaxy Zoo style platform with like the quantified self movement, where you could actually run kind of like epidemiological experiments on what people are already doing with their lives? So kind of feeding back their data into them, into the database that you have, and kind of outputting, I don't know, some coffee usage, and seeing something like that.
I'll let Brooke take the first point in a second about education, but on the second point, yeah, we've talked a bit. I'm not sure it's exactly the same problem, because what we've optimized for, as you've seen, is classification of data, as Brooke pointed out, that we understand and we verify. So there are people who do plenty of citizen science with user-reported data. We haven't done that. One interesting example of what you're talking about, I think, came up in discussion with the public health people here in Oxford, where for conditions you could think of arthritis or something like that, there's a lot of sort of folk knowledge online that, you know, for example, cutting out bread out of your diet will improve your arthritis symptoms, for example. Now, no drug company is ever going to run a tested trial on that. There's very little commercial advantage in being the people recommending cutting out gluten. Maybe, you know, anyway, no one's going to run a randomized trial, but if you could get a group of patients together, it would be easy to put them into a randomized trial online and get them to share their experiences that way. So there's a site called Randomize Me, which is a sort of thought experiment in how this might work. I think it needs a bit of work, but we've certainly talked about how one might look at specific patient groups like that. I think that could be very, very interesting. On the education point?
Sorry, what was the question again?
It was about educating people, putting a high school curriculum into
in fact, that's something we've been talking about doing. There's several questions related to that, how you do it, whether you change the focus then from science to education, where do you draw the line between calling it citizen science and calling it outreach and things. But it's very worthwhile, and I think a lot of it sort of drops out naturally. I think in terms of saying, you know, you've classified 10,000 galaxies on Galaxy Zoo, you know, would you like to know more about galaxies? You know, that's something that we've not done as much as I think some people would like, but there's potential, and we're starting to try it out.
Yeah, we do know that people who take, this is probably not surprising, but we were pleased to see it, that people who take part in Galaxy Zoo learn more about galaxies. but they learn stuff that we don't tell them on the site.
So in that way, we were testing it. We kind of had to deliberately not tell them in order to answer that question of whether they will learn
what
themselves.
that means, I think, is that the sites are acting as engines of motivation for people to go out and be inspired to learn stuff. And I think as a science communicator, that's really exciting. We normally only get to talk to people who've already decided they want to learn stuff.
At the same time, we're also developing, lesson plans and so forth based on various projects to go into classrooms, even if it's not directly on the site. So there are many aspects to address this.
Great. I'll gradually work back.
I find it's probably more a thought or something, but recently I'm using Khan Academy quite a lot for my 8-year-old here in Oxford, and he's like, and he comes home and he starts playing. And what you said about badges, I know it's kind of an obvious point, but it's not obvious when you're doing it. When he's been using it, I've been going, great, he's coming in. But at what point does he do it for the badges versus the love of the math, right? And I think that's fascinating, because I'm not seeing where Khan Academy today, at least I'll go and look at it again, where he's solving a bigger problem, or he's contributing to something bigger and more meaningful.
Yeah.
I don't know if an 8-year-old does it, but they do. I mean, they're doing something, a thing that he collaborates with other people on, something. So I think it's fascinating. I think that was quite interesting.
Yeah, I think my response to that is I think Khan Academy are clearly doing something right, because the way that people use that site is really fascinating. And I think this isn't supposed to be a criticism, but I think one of the really interesting things for somebody who hangs out with a lot of web developers is there's nothing slick about Khan Academy. It's just content delivered well. And it turns out that's with badges. But I think I think the place where for me the badges really cause a problem is when I'm trying to change people's attitudes. So there's two parts. I've talked mostly about these projects as a practical intervention to try and get stuff done. And gamification for that is one thing. I still don't think it's easy to do well, but nonetheless, it's that. But if I'm trying to convince somebody that their attitude to science is wrong, that they should consider science something they do in their lives and they should feel positive about it, bribing them with a badge really feels bad. So if your 8-year-old already loves maths, then the badges, I can imagine, act in parallel as an extra incentive. But if he's somebody who hates maths, I suspect no badge in the world is going to change that.
Okay. Moving backwards, who's next?
So you talked about development of a software program to do this rather than humans. Is there a role for the data that you've got there to teach the machine, and then the machine could learn from, and so the humans could be used to ground truth what the computer's learning?
Yeah, so do you want?
I think, well, it's already been done with the Supernova project, is our kind of showcase project for having already done that from start to finish, that the humans provided such a large training set for the machines that the machines could then match the humans' abilities. And so in that case, the project then wasn't necessary anymore. I think ideally, in what we'd really like to do is have the machine be part of the classification interface and say, I think I have a guess at what this is. I'm going to fetch a classification from a person and use that and their expertise and my knowledge of that to refine my guess and decide whether or not I know what the answer is. And then keep doing that until the machine decides I'm finished with this classification. And that was a lot of what was.
Yeah, strangely, from the perspective of our software platform, a machine is a very predictable human. So if I'm building a routine that decides which human should classify a particular image, it's trivial to put machines into that loop and make an active decision about what's worth a human seeing and what a machine is worth seeing. And we're doing a lot of that to see where the balance lies. There are also interesting edge cases. So, for example, one can imagine we have a project using, I can't believe I didn't put any animal pictures in the talk. We have a project using motion-sensitive cameras in the Serengeti. And it looks likely, we're still working at it, that what machines can do is say all of these 2,000 images show the same sort of animal, but they're not able to distinguish the type of animal. And then if you classify one of those well, then you suddenly get 2,000. So there are lots of interesting ways to put this together. Ian and the school have introduced me to Gary Kasparov's idea of extreme chess, which is like open book chess. So you're allowed to cheat. You're allowed to have a computer helping you. And what's fascinating about that is that firstly, the combination of man and machine usually beats either on their own. But secondly, the kind of combinations that win tend to be not the very best human with the very best machine, but rather creative use of machine intelligence by a small crowd of humans. And I suspect you're going to hear more about that throughout the term.
Great.
Hi, thanks for the talk. It was a fantastic talk. So I'm interested to know about the person profiling, behind the whole thing. So I'm just wondering, you basically profile people to, to smoothen the results of the research, right? I mean, like, have you ever thought? I mean, like, you probably thought of something and it probably reverse the process. Instead of trying to, trying to classify people to get better results, have you ever, thought of reversing the process, or, trying to smoothen probably psychological experimentations, and then, probably give contribution to the psychological experimentation?
Yeah, we have a little. I'd really like to work, if there are any anthropologists in the room, I think what we actually need is some digital anthropology, because these people form communities, and a lot of the work that we didn't do about it is a lot of the work that gets done is in discussion between people, and it's fun to follow that. So yeah, we have looked a little. I think mostly, I mean, I'm a physicist, so it's always slightly difficult for me to jump. But the thing that worries me about those studies is that they mostly tell us about whether we've done our job right in designing the project. So I'm not sure it's easy to get to fundamental psychology instead of just finding out that we put the buttons in the wrong place. One thing we are looking at is in the discussion forums that accompany the project, we have several people, particularly in the Research Center here, looking at the development of technical language by a community. So as people come in and they're not scientists, but they go into Planet Hunters, you can see that over time they pick up more technical terms and there's learning happening. And so the psychology that we're particularly interested in is how that happens, how somebody begins to decide to sound like a scientist. Terrifying prospect, perhaps.
The woman at the back behind you.
So I'm just curious, I think part of the momentum around citizen science projects is not only making science more efficient, but making it more participative, and moving from science as being technocratic to more democratic. You mentioned that part of the project aim is to make people think differently about science. So I'm just curious as to how this is actually getting science to think differently about people. One of my criticisms of crowdsourcing the citizen science projects is that they tend to use citizens as tools for science rather than actually encouraging scientific literacy or capacitation or that kind of thing. So I'm just wondering what your take on that is and how you actually see, I guess, that gap is being resolved.
No, I think those are really valid and interesting questions. But I think one of the things that's happened from the beginning with our projects, I wish I could claim that we'd predicted this in 2007, but we didn't, was that we immediately saw the growth of a community who wanted to go beyond just classification. So I'm very comfortable with crowdsourcing as a gateway to meaningful engagement with science, to authentic engagement with science. Something happens to people when they realize that what they've just done on some website in their lunch break has actually made a difference to what we understand about the universe. So that's the gateway. What I'd like is to give as many people the option of going beyond that. And so that's why we're working on projects like Quench that give people tools to explore on their own, give people novel modes of publication so that not all the scientific discourse is driven by professional journals written in frankly incomprehensible jargon half the time. And so we do think about that a lot, and it's something we're working hard on. However, I think there's an equal and opposite danger, which is that one can easily make the assumption when you start talking about that stuff that everyone wants to be a professional scientist, and you run into deficit models of science education and so on. And so I think I want everyone who participates to understand that they've done something real to change scientific knowledge, and I want those who want to go further to be inspired to do so. But I think we're still exploring how to balance those two things against each other. Science, as any PhD student will tell you, science has a lot of drudgery in it. Yeah, and there are days when you come into the office and what you do is a routine task for hour after hour. So if people want to do that as a way of relaxing or in front of a screen or instead of watching Brian Cox, then I think that's fine. But what I want them to take away is the idea that that was different from playing Angry Birds. And it was different because it was real.
As an example, one of our, in Galaxy Zoo and across actually many of our projects, is one volunteer who is so involved that she's become a moderator on our forums and our community, and she is in many ways more expert than I am at galaxy morphology, but she doesn't want to write the papers for Quench. That's just, she has chosen that as not her role. She wants to stay at a different level of participation. I think it's important that we validate that choice.
Yeah, and there's one other thing I should say as well, is that the weirdness of our current state in Zooniverse is that for a project that talks about citizen science and citizen engagement, it's an incredibly top-down model because we want this authenticity. We are the judges of authenticity, and we say this is a real project. That Supernova project that put itself out of business, which we see as a good thing. So we turned, as soon as we found out the machines had taken over, we turned the project off because it's no longer real in our sense. If you think about that scenario from the perspective of a classifier, people were coming home every night and doing 5 minutes of Supernova Zoo. The weirdness is that nothing changed in their experience from the day when it was real science to the day when it was a waste of time. And so there's some strange issues. We're actually looking at ways to hand more of the control of the community to the citizens. But that's a research project in itself.
Yeah.
Yes, Chris mentioned that he was still writing funding applications, and I wondered who he was writing them to. Was he writing them to the conventional funding agencies, or was he addressing them to his publics that he's recruited to these projects?
Yeah.
So do you see crowdsourcing meeting crowdfunding somewhere along the line, and might both meet reality television at some point as well?
So I'm distracted by the reality television. I was thinking of all sorts of formats now. Martin's School Live, I think, could be an interesting series.
It is.
But yes, hello world. No, I think, so mostly it's conventional funding at the minute. We have a chameleon-like ability to be a computer science project or an education project or an astronomy project or ecology. And we've been generously funded, so that's good. We're working hard on building the platform as quickly as possible so that we won't need to be generously funded when this ceases to be sexy, because I want this to be a long-term thing. In terms of the crowdfunding, we have dabbled. So one of our projects, Snapshot Serengeti, needed a few tens of thousands of dollars to fill a funding gap, and they had a passionate community who really cared. And I will say only that I think we got them to their funding target, but it was a lot of work, and it wasn't easy to translate the interest that people had that led them to donate time into people reaching into their pocketbooks. So my guess is that that's a general rule, and that those two types of engagement don't necessarily correlate. And we got some angry emails that I took very seriously from people saying, look, you've already had my time. Why are you asking for money? And also people who said, look, if you can't fund this, how do we know it's real science that you're doing? So crowdfunding is fascinating and interesting, but it's not a panacea for these things.
And if there's anyone out there on the web that wants to fund any of this, do contact Chris or me. Yeah.
Hi, thank you. This follows on from the penultimate question about different sorts of crowdsourcing and citizen science, because basically all the examples you've been given today have been about using people as classifiers.
Working with people as classifiers,
sure. A model which has been used by the Open University, by the RSPB, counting stuff.
Sure.
And the way that then has to get dealt with, it seems to me, are quite different from the sorts of relationships. And incidentally, I'm an anthropologist.
Okay, great. We should talk. Yeah, no, I completely agree with that. And we've obviously talked about our model, which it solves one set of problems. It's actually a more recent problem, whereas the problem of distributed observers is, of course, an old one. The people to look for that are, I think the people who do it best are the ornithology lab at Cornell, who run a project called eBird, where people report bird sightings. And what's the main problem, that they have two problems that we don't. Firstly, They're trying to engage a specific community that already exists and already has opinions about whether it wants to give its data to Cornell. And so they found that we find that our audience is motivated by a general sense of altruism. Their audience was motivated not when they tried that to get bird watchers to send in their reports to scientists. That didn't work very well. When they created a league table for bird watchers, and you could find out whether you were top in your town or your city or this month or whatever, that's where they got their data from. The other thing they have to worry about, of course, that we don't, that Brooke talked a bit about, is data verification. So if I say that dodo walked down Oxford High Street, they need to establish that I don't know what I'm talking about. And they have incredibly sophisticated models for doing that. It's really impressive stuff. And rather than try and give a 2-minute garbled version, you can point everyone to their site. It's really smart. They are different communities, though, in places where you'd think they'd overlap. In my experience, when I go and talk to amateur astronomers, I talk to amateur astronomical societies, you'd expect they were our original target audience for Galaxy Zoo. And yet we find that while they have heard of Galaxy Zoo and they often use it in their outreach, they're not huge users of sites like Galaxy Zoo because it's a different kind of astronomy. And so there are still distinct communities. We have a project just starting, funded by the AHRC, to compare 19th century and 21st century citizen science, which I think will explore exactly this issue. So maybe that's the talk for a couple of years' time.
Great. I think just last question here.
Yeah, just thinking about the translation over to humanitarian crises. You've obviously talked a lot about how you can do the mapping of behaviour to improve the verification process. I think for me what's interesting is once you're in a humanitarian crisis situation, obviously speed is of the essence.
Yeah.
And yes, you'll probably recruit the volunteers very quickly, but how, I mean, I know this is still early stages, so you probably don't have the answer to this, but how do you answer that question of, well, how do you get that verification process done quick enough? Because, people could get it very wrong.
I think the first answer is you don't try to do it at the first crisis. You have to have that in place in advance. And it's a hard problem because, and particularly in Zooniverse, we get a lot of traffic. And so you've got lots of people and you have to put all that together and do this right. And so you can do it. We did it with space warps. That was over a time scale of a few hours. So we'd like to do even better than that. So we're working on, a lot of it is sort of optimizing your code. And a lot of it is finding better ways and more efficient ways. But I think that the kind of overall answer is that you practice and you get much better at it, and that's what we've been doing.
Yeah, I think there's an open question. I mean, one thing, there's a question we concentrate on the live aspect of disaster relief, but we've talked with people in the school about when there isn't a disaster, doing things like vulnerability mapping and so on. So at least some of the volunteers would come into a crisis with a track record, and that makes life much easier.
Yeah. There's some communities that already exist that are willing to help and can be trained and can train others, and so. Yeah.
Great, excellent. Just before we thank Brooke and Chris, let me remind you about the forthcoming events here at the school. So this is the first in our seminar series on the changing dynamics between man and machine. Next Thursday, at the same time, the focus will be on M-Health and the interface of smartphones and human health improvements from Fred Hirsch and Carl Gifford that are in our George Institute in the Oxford Martin School. The following week, the 13th of February, Anders here will be talking about the interface between brain and machine on artificial intelligence. On the 20th of February, the issue that was raised on biodiversity and how smart apps and other things can be used to map biodiversity, and that's from our group on biodiversity and resource stewardship, led by Professor Kathy Willis. On the 27th of February, Alexander Leavinghouse and Dapar Kende on drones, so ethics and the new technologies of armed conflict and machine intelligence. On the 6th of March, Nikki Trigoni and Professor Kwayakoza from our group on the future of computing on sensors and the ubiquitous sensors and their machine interfaces with humans. And the final one on the 13th of March, Carl Frey and Michael Osborne on whether we're going to be replaced by robots, the implications for jobs and employment. So it's a great seminar series. I do encourage you to come and to tell your friends about it. In addition to that, we have a lot of other things happening. Tomorrow, here at 4 o'clock, we have David Christian on Big History, the place of human beings in the cosmos. Next Tuesday at 3:30, we have Andrew Haldane, who's the Executive Director for Financial Stability and Deputy Governor of the Bank of England, on Is the Financial System Safe? And he's also worked a lot on complexity and other issues. Really terrific guy. On Saturday, the 15th of February, there's a student-led event in the Sheldonian which brings together a lot of the work of the Oxford Martin School across many different areas, called 21st Century. On Monday, the 24th of February at 5:30, there's Kumi Naidu, who's the Executive Director of Greenpeace, on direct action, when and why. And the final event that's scheduled so far, or no doubt new things will crop up, is on Thursday, the 6th of March, to mark International Women's Day, Baroness Helena Kennedy talking on the fight for women's rights and learning from that. So a really great series of seminars and lectures this term. Encourage you to come back, and I'd like to really thank Chris and Brooke for getting the term off to such a great start.